let's take a look at lesson 10.2. And before we do, let's remember what we did on 10.1. So number 1 here, it says, what's the 6th term in the sequence? So first question I have before we actually get through the math, how would you find 6th term? Not how would you find? What's the symbol for 6th term? Let me start there. What's the symbol for the 6th term? A6, good. And a second thing I want to review is vocabulary. When you see the word sequence, that implies something about the numbers as opposed to a series. What does a sequence do? They don't combine together to arrive at a sum. They just are separated by commas. So on this one, we also last class, we learned about arithmetic series. That's ones that add and subtract together. We learned about geometric briefly. I think you only saw one. That's where they multiply and divide. We also saw a quadratic. That's where it's like the first one adds by 3, the second one by 5, the next one by 7. It's like the value you're adding by also adds by a certain amount. And then we saw one more that was cubic, and that's kind of the same thing as quadratic, except it's another level down what it's grown by. So that's a little bit harder to say verbally, but we learned about all 4 of those. This problem is one of those 4 sequences. Can anybody figure out what is happening to get from the first to the second to the third to the fourth? So it is going from negative to positive back and forth, which means you cannot be adding by a certain amount, because adding would either make it more positive, nor it could be subtracting, because that would just make it more negative as you go on. So it can't be adding or subtracting, which means these 3 are out. It's got to be geometric. So if it is geometric, hey guys, can you all be with me? If it's geometric, what are we adding multiplying or dividing by? Have you figured it out yet? What about -3? Multiply, dividing. So technically we're dividing by -3. Another way of saying that is with geometric, you use the symbol R, as we'll find out next class. And the way you would just write it by symbols is by saying R is -1/3. That means like multiply by -1, divide by 3, or you could say multiply by 1, divide by -3. So that's basically what's happening. If that's the case, what would come after the 3? What is 3 times -1/3? -1. Okay, so I'm gonna extend my list here. So we now have a -1. And then if we needed to find one more term, we would take that -1. And what do I do with the -1? -1 divided by -3, or multiplied by -1/3. And what do we get? +1/3. And that would be our value. 1, 2, 3, 4, 5, 6. A6 would equal 1/3. 1/3, +1/3. That'd be your solution. All right, let's take a look at now number 2 after doing a little bit of review. It says, what's the 4th term in this series? Again, what's the difference in a series and a sequence? A series does add up. So when I say what's the 4th term, am I saying just to type that into the calculator? Let me just get a blank calculator. Am I saying the answer should be, how do y'all get this symbol? Do y'all remember? You just type in sum, S-U-M, and type in sum. Am I saying that all we should do is type this in? Oops, it says K. Let me go K. Not that it really matters, but I'll just take this. K is 5 to 9 of K squared minus 3. Would this be my answer here? Why is that not the answer?
It's just adding all of them.
That's the sum. Is that wanting the sum? No, it's not even asking for the sum of the first 4 terms. It's just asking the 4th term. What's the symbol for the 4th term? A4. This right here, the sum, I'll put it as an S. The sum is 240. That's not what we're needing. We're needing A4. So how can we find A4? Well, it all comes down to how sigma works. The way sigma works is it starts with what we call the lower bound. This is our lower bound, and it plugs in the lower bound to find the first term. So A1, how it'll work is A1 would equal, and you would plug in the K, 5 squared minus 3. You see how I just plugged that into the equation there? That's exactly how you would find your first term. How would you find the second term? Now that I've told you that, how would you find the second term?
You do the answer. Take whatever you get from that and then put it.
That's a good idea. You don't actually, that would be if it was recursive. You don't actually have to do that with this one. So what does the calculator do after it plugs in the 5? After it plugs in a 5, you know what it plugs in next? A 6. It plugs in a 6. So how would you find the third term? Let's see if you now caught on.
7.
You'd plug in a 7. So it'd be 7 squared minus 3. How would you now find the fourth term? You got it. Fourth term would be 8 squared minus 3. You just plug in an 8. So I plugged in the 5, 6, 7, and you would get to an 8, and you'd plug that in. This problem would keep doing the calculator. What it does is it keeps doing this process until it reaches the upper bound. Until it reaches 9, that's when it would stop. So this one, how many terms are in this series right there? How many total terms would there be? Would there only be 4? Answer, there would be 5 terms. 5 terms. Whoops, minus 3. The reason it's 5 is because there are 5 separate numbers that k can be. 5, 6, 7, 8, and finally 9. That's how there's 5 terms. Okay, so we want to know the fourth term. What is 8 squared? 64 minus 3? 61. So that would be our fourth term is 61. If you added up all these, you would come up with 240. I'll just prove it to you real quick. That's 25 minus 3 is 22. 36 minus 3 is 33. 49 minus 3 is 46. 81 minus 3 is 78. If you add those numbers up right there, you will come up with a sum of 240, like the calculator said. That's how the calculator gets 240. That's what's happening. That makes sense. So I wanted you to see that so you kind of understand how sigma actually works, like what the calculator is doing there. Okay. Number 3 here. How many terms? Oh, that gets us to this one. How many terms are there? How could you find out how many terms there are? Well, let's see. On the previous problem, how many? We said that there were how many terms? 5. Is 9 minus 5 equal 5? So there is a rule, the upper bound minus the lower bound plus 1 more, because here's why subtraction doesn't work perfectly. If you took 21 and subtracting 11, that's actually taking away 11. We're supposed to use 11. So you actually would take away the first 10 values of k, 1 through 10, and you would start at 11. So it's really 21 minus 10. Or said another way, 21 upper bound minus lower bound plus 1 more. So this one's going to have 11 terms. But here's probably the easiest way so you don't get confused. Let's just write out the possible k values. What can k equal? 11, 12,
13, 14.
Okay, it can equal any number between 11 and 21. How many numbers there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 terms. There would be 11 terms. So again, the formula for this would be the upper bound minus the lower bound plus 1. Again, the reason that's plus 1 is when you subtract the lower bound, you're not actually supposed to take away the number 11. That's where you're supposed to begin with. So you have to add it back. So it's upper bound minus lower bound plus 1. That would always be the number of terms. Equals number of terms. All right. And finally, number 4. What is the value of an given this series? Do you know what that symbol can mean if it just says an? What does n usually refer to?
Which number?
The number of terms. And typically, remember, it can mean anything, like any number, or it could mean the number of terms. So in this problem, what do you think it's saying? What is the value of any term given this series? Or what is the value of the last term given this series? Which one do you think makes more sense? The last term. This one here, the n is referring to the number of terms. So it's really saying, what is the value of the last term? That's the way you can translate this. So it can either be any term. Hey, there's a lot of voices going on that are not with me. That's a problem. Or it could mean the last term. So what is the value of any term given the series, or what is the value of the last term given the series? It's last term that we're looking for this time. So I'm not looking for any term, I'm looking for the last term. So how would you find your last term? Good idea, but that will be the term number, but that won't actually give us the value.
We can go through the little thing we just did. on number 2.
There's a shortcut. Which one will be the very last one?
A13. Is that 13?
It won't necessarily say A13. That would be the upper minus lower plus 1. What is 13 minus 7? 6 plus 1 more?
7.
It will be A7, but you do not plug in a 7. What would you plug in to find your last term? The upper bound. You plug in the 13. It would equal negative 87 minus 5 times 13. So why is it A7? Is it because this is a 7? No.
Because that's the number of that.
That 7, it's a coincidence that those are the same. It's really because 13 minus 7 plus 1 equaled 7. Upper bound minus lower bound plus 1 equaled 7. That's why that's a 7. Why do we plug in the 13? Because that is our upper bound, and the upper bound is the last term. That's not how you spell upper parent. Let's put in 2 U's. Upper bound. So the last term is the upper bound. That's why I plug in. Any ideas what that value is? Negative 87. Was it minus 5 times 13? Negative 152? So that would be our solution here. So really, it only, when it says value, it's only wanting the negative 152. The A7 is just how you would refer to it in the sequence. So hopefully we remembered a little bit from last class. Sigma notation. A lot of people overlook this because it's so easy to get an answer from the calculator, but you need to understand how it works. When I say you need to, I'm telling you right now, I'm preparing you. When I test you, you need to understand how Sigma works more than just typing the calculator. That would be the easiest test ever, and I could give you that, but I want to be doing a good job as a teacher preparing you if I only just made it the easiest test ever. So you will have to understand how that works. So one more time, how does Sigma work in the calculator? What does the calculator actually do? What's its process? Adds up what? What's it do first? Let me ask that question. What's the calculator do first? Plug in what? The lower bound. That plugs in the lower bound. After it plugs in the lower bound, what does it plug in next? The number after the lower bound. And it continues on that process until it reaches when? The upper bound. That's right. All right. With that, today we are specifically focusing on arithmetic sequences and series. So part of arithmetic is you could consider quadratic and cubic as being arithmetic just because it's a second, or in cubic's case, a third level of adding. But we are dealing with arithmetic. Let me pause. I'm going to give you a formula chart real fast. So I'm going to pause this recording. All right, for those online, let me show you where you could go. Is if you go to Clever and just click on my page, and from right there, you will see the formula chart within my pages resources. Or if you don't want to do that, if you want to go through our Power School Learning digital classroom, any single lesson you click on will also have this formula chart. So we're on chapter 10, lesson 2. So when I open this up, you'll see formula chart right there as well. And if you click, I'll go ahead and click that just to have it up today. What we're looking at is sequences and series, which is on the front page. So here it is. Let me see if I can zoom in any more here. Today we are looking at arithmetic, and what we're going to see right off the bat are these terms right here for arithmetic. That one right there in particular. Okay, so that's what we're looking at is arithmetic sequences. there's going to be this word or phrase, the common difference. And so here's where it comes from. There, in an arithmetic formula, if you look at it, it'll say AN equals A1 plus N minus 1 times this letter D. The D is the common difference. That's how much it's changing by each time. So I'm explaining the formula right now. What I'm explaining is the formula. So I'm going to just say formula chart, actually, so you know where I'm getting this from. That comes straight off the formula chart. If you look on there, that is the arithmetic sequence right there. That's the formula. Now, here's what I want you to know. These two, this is very important because the formula chart does not tell you this. These two numbers right here correspond to one another. Those two ends correspond. So what I'm trying to say is, if this is A7, guess what number goes right there? 7. If this is a 10 right here, guess what you can say about this over here? It's A10. Okay, not only that, but this is what really the textbook doesn't even walk you through, but it's very helpful to know. These two ones correspond to one another. Those two correspond. So what am I trying to say? What if you don't have the first term, but you have the third term? Could you put A3 right here? Answer, yes. But if you put A3 right here, it's got to be N minus 3. And if you do that, the formula always works. It makes life very easy. You know that. Okay. So there's some verbiage right there. Common difference is the D. You know, first term, nth term is technically how you would read that. It could mean any term, last term, whatever. And first difference is for most. Second is what we call quadratic. Just put a note there, quadratic. Quadratic is when it's the second level. That's the common difference. Quadratic. And a third difference, I think we see one today. Third difference would make it cubic. So I'll just add that in. Third difference would be cubic. So we talked about that already. We'll go ahead and add that to the notes. All right. So let's use this. First problem. It says determine the common difference and the next 4 terms of the arithmetic sequence. So here's your formula if you need one. Most students on arithmetic don't actually use this formula, but here's the formula for arithmetic. Arithmetic. Your formula for the common difference is this. The common difference equals any term minus the previous term. And so if you remember this, AN can mean any term. AN minus 1 means the term that came before it. So this would, I would translate that previous term. So any term minus the previous term will give you your common difference. So in this case, if you wanted to use the formula, some students already know the number. Have y'all figured out what it's adding by?
17.
It's adding by 17. The way you can mathematically get that is say D equals negative 36 minus a negative 53. So what happens with two negatives? I should put that in parentheses so you can see that that is two net minuses make an addition. And if you type this in your calculator, we would get positive 17. So that's our common difference. So this problem says not only find the common difference, it says find the next 4 terms in the sequence. So what I'm going to do is I'm going to put a little white over this. Let's find the next one. If you add 17, what comes next? Negative 2. Okay, so we add negative. We have now negative 2. What comes after negative 2? Positive 15. Good. And the next one? 32. And finally, last one. 49. These would be our next 4 terms. Just to remember, you could call 49 a sub what number? You could refer that as a sub 7. What's another symbol that might represent it? You might see it represented as AN, because AN can also mean the last term. Okay, just to make sure you see that. And I'll put that in parentheses because AN can also mean any term. So in this case, it means last term over here, and that would mean any term. Okay, your turn. DOL number 1, I want you to find the common difference as well as the next 4 terms given this arithmetic sequence. And I say sequence because there are commas separating them. So you go ahead and do that. All right, let's take a look now at example 2. So here's that formula I was talking about right here. This is on the formula chart, this formula right here. So on your notes, you can go ahead and like circle it up, whatever, so you know it, but you can also put formula chart, and that we have a link to. So I was showing you earlier through Clever, you can either click on Brent V. Voorhees page right there in your Clever, or you can go into the digital classroom, Power School Learning, and also click the formula chart there if you ever want to see the formula. One more technique. Technically, if you went to the Desmos and opened up arithmetic, this is calculator number 10 we're going to use today. I don't know why that didn't load there. Let me refresh this. If you open up number 10, I show you the formula right there. And yeah, anyways. All right. So it says find both the explicit formula and a recursive formula for the nth term of the arithmetic sequence shown here. Okay, so help me out. We're going to use that formula that I just wrote down a second ago. Remember the formula we said was, the formula chart says this, that AN equals A1 plus N minus 1 times D. Okay, so let's first start with, do we know what D is yet? How could we find it? Not 14 minus 3, but 3 minus 14. You take any term and subtract the previous term. So it'd be technically 3 minus 14. So what would be our answer there? Negative 11. So if you did the first minus the second, you would have got positive 11. That obviously isn't right. It's just being subtracted. So our common difference is negative 11. So we just figured that out. The common difference is negative 11. Now, if you have the first term, you can plug it in there. What if you did not have the first term? What if I had A1 there and we didn't know what it was? Could I plug in the second term?
Yes.
Yes, you could. But if I plug in the second term, let's just now go back to what we had. If I plug in a 3 there, what do I have to put over here? I'm sorry. If I put in the second term, which happens to be a 3, if I put A2, which is 3 right there, if I put a 3 there, what number has to go here? And a 2, because it was A2. That's right. Okay. So at this one, we have 14. So let's just go ahead and plug in 14. A1 is 14. That is A1. Let me draw that little arrow there. That is A1. And so it'll be 14 plus, and for the formula, you would leave, for the nth term, you would leave n alone. That's what, if you're finding the nth term, you would leave n alone. So we're not going to mess with n. And so let's just plug this in and simplify for our answer. So a sub n would equal 14 plus n minus 1 times negative 11. We can simplify this by distribution. So we have 14. What is n? It's a positive n times negative 11 going to be? Negative 11n. And then I have a negative 1 times a negative 11 plus 11. So this comes up, and this is what they call explicit. The explicit is like the formula chart formula. The explicit formula would be this when we simplify. Explicit formula would be AN equals, I didn't even tell you, these two combined together. What is, change color, sorry. What is 14 plus 11 more? 25. I'm going to say 25 minus 11n. That's the explicit formula. Now the recursive formula needs 3 things. Recursive formula is the easiest to write down, but it's the longest if you ever have to solve. What do I mean? If you remember last class, recursive was when I asked you what's the 5th term, but before we found the 5th, we had to find the 4th. Yeah. Before we had found the 4th, we had to find the 3rd. Do you remember that problem? Those problems? I was just making sure someone was paying attention in here. Luckily, Alexandra saved y'all. Yes. Wasn't my mistake. Yeah, it's your mistake. Yeah, good job, Alexandra. You're right. That does need an in there. Great. Okay. So here's how the recursive formula works. It always has 3 things. the first thing you do is you state the first term. What's your state the first term? 14. That's the first thing you have to do. You state the first term. Okay, let me just put these little steps over here. State the first term. Second thing is you're going to say the formula is any term equals the previous term plus the common difference. What is my common difference? Okay, so I'm going to take away the plus and make it minus 11. So over here, step 2 is an equals an minus 1 plus d. That's just the formula you plug in. So in this case, all I did is I plugged in d, which is negative 11. And then finally, third, you say that n is greater than or equal to 2. What's up? It is. It's plus d, but it's a negative 11. So it becomes plus a negative 11, which is the same thing as just minus 11. And then you'll put n is greater than or equal to 2. And this is always the case unless it is a Fibonacci. Fibonacci is where you needed 2 previous to get to the third. Do you remember that one, the tree growing problem? So anyways, that's what you do really on a recursive. The 2 things you're responsible for is plugging in the first term and plugging in your common difference, and you'll have those formulas. That one's the easiest to find, but it takes the longest to actually do anything with it. So explicit takes a little bit longer to find originally, but it's very powerful from there. The explicit formula is also what we can use for sigma. Put a note over there, is used for sigma. Is used for the sum, I could say. Is used if you need to find the sum. All right, so that's the explicit. All right, with that, you have DOL number 2. And you have a lot going on. I want you to notice this is the explicit. This is the recursive. Remember, the cursive is going to have 3 things as a part of it. It'll have 3 things. So you first do the math to find your explicit, because that's what's going to be powerful for you anyway. So if you want to solve a problem, recursive, we'll just then write down those 3 things that I told you. DOL number 2. All right, let's take a look at example 3. So now let's apply that explicit formula, or as a formula chart would say, the nth term formula. So it says find the 41st term. So here what I'm doing is, if my formula chart says this, my formula chart, again, you can look on the one digitally over here, or for those in classroom, I gave you that one, or if on your notepad, note packet, it's also there. The formula chart says this: an equals a1 plus n minus 1 times d. And so if I'm trying to find the 41st term, that's a sub 41. Where do you think I place a41 on the formula? An. That's going to become my an. So I want to find a41, which means I have substituted. The only thing that's actually changed is n is 41. What's our first term?
11.
That 11 is my a1. Now on this formula, I'm not going to leave an n there, because what do we say? What have we already substituted in with?
41.
Yeah, that's right. N is going to equal 41. So I put a 41 minus 1 times the common difference. Now, how do we find the common difference?
Second term.
You take any term and you subtract the previous. So I heard a lot of students say take the 4 and subtract 11. What do you get? Negative 7. We could check. Do the others appear to be subtracting by 7?
Yeah.
All right, good. So D is negative 7. I'll put it in parentheses because it's negative. So whenever I simplify, I will have our solution. It's going to be 11 plus, what's 41 minus 1? 40 times negative 7. So I did that inside of that parenthesis first. 40 times negative 7 is negative 280, but just to make sure we don't make a mistake. 11 plus, I already forgot. 40 times negative 7? Answer would be 269, negative 269. So our answer here, a sub 41 equals negative 269. This is as good a time as any. Show you how to use the calculator. I'm going to pause for a moment. Go ahead and pull up that calculator from the Desmos list. It's the calculator number 10. Go ahead and pull that one up. Okay, let me walk you through how this calculator works. Remember how I said that the a sub 1 and this one correspond? When you open this up, the first thing you can do is change AT. And if you look at the formula, like there is no AT. T is referring to the ones. So here it says our earliest math term available. What is our earliest term available? 11. So put 11 there. AT is 11. And the T, it says T is the term number. So I want to make this T be 1 because it is A1. So that's telling the calculator A and that little T there, we're saying T is 1. A1 equals 11. That's what we just told the calculator, is that A1 equals 11. Now next, you want to go to the last term in the sequence. Now this we don't know. So we're just going to put an X here. We don't know what that is. So we don't know how many. Oh, we do know how many there are. How many are there going to be? 41. So N is 41. That we did know, but we don't know X, which means what is the last term? The common difference. What is our common difference on this problem? Negative 7. So go to your D and take that, negative 7. And so there's the formula for that right there. Okay, and it says the X value is the intersection. So if I zoom out, I should be looking for an intersection, which it's over here on the negative side. If you zoom out, are y'all getting negative 269? That's the answer. That's what we had. Negative 269. So that's how you can use the calculator if you don't want to apply the formula. That's how it works. You just plug in your values. The tricky thing, I say tricky, but it's made to make complex problems easier for you, is that the AT, that just means it doesn't have to be the first term. For example, what if we did not use the first term? What if we wanted to use the second term? Could I have plugged in a 4 here? Yes. Check this out. If you plug in a 4 here, right now it won't give you the correct answer. But if you change the T, the 4 is which term number? If you put that as a 2, it'll calculate and give you the correct answer just the same. Because that'll happen. They'll give you sequences where they don't give you the second term, the first term, whatever. They'll give you like the 13th and the 50th. Alex does this a lot. They'll say, here's the 13th term, here's the 50th term. Find the common difference or whatever. And so it's very helpful if you know how to use this formula. And that's all it's doing is it's changing the ANs and the A1s. Yeah. All right, so let's do part B now. It says, find the first term. So find A1 of the arithmetic sequence for which A44 equals 229 and D equals 8. So if I'm using algebra first, I would use my formula. AN equals A1 plus N minus 1 times D. I would do that first. Second question I got for you, or not second question, first question, but step 2 here. What can I plug in?
Your N's.
N, what is N going to be?
44.
Okay, so we're saying that N equals 44. So on the place of AN, don't actually put A sub 44. There's a better choice than A44. What's the better choice to plug in there? Let's put 229. 229 will equal, do we know the first term? No. Do we know how many N's we have?
Yes, we have 44.
44 minus 1. And do we know our difference?
Yes.
8 times 8. So we could just simplify this to get our answer here. 44 minus 1 is 43 times 8. Anybody have a clue what that is? 344 maybe? I'm gonna press enter to get a blank line.
344.
I was right. I'm right. It's Nice when mental math works. 229 equals A1 plus 344. Okay, now how would you solve that algebra? Okay, so we need to subtract 344 and we'll find our first term. Negative 115. All right, so we found it. A1 equals negative 115. So this was a little bit higher difficulty. Let's check the calculator, see if it agrees. All right, so back on the calculator. Give you a second to pull that open. Do we know the first term? No. So what do you put for a t here if you don't know the first term? X. That's our x. Do we know what little subscript number it should have though? And it should be a 1. We're looking for A1, the first term. So I put that as a 1 because that's what I want it to be, A1. Okay, now do I know the last term?
Yes.
Yeah. What is our AN value? 229. And we know that is the 44th term. So that you make that N be 44. So that's really the subscripts. The T and the N are the subscripts. Okay. Do we know our common difference? 8. So now that I typed everything in, and by the way, it would show the sum down low if you go to that. You click there, and the answer is negative 115. So did we do it correctly? You better believe it. We did that correctly. Probably should throw that on there so you can see what I did later. That's the answer. All right. Your turn. You can find the 25th term using either algebra or the calculator. It doesn't matter to me. Just find your 25th term. Deal number 3. All right, example 4. Write an arithmetic sequence that has 5 arithmetic means between 6.2 and negative 1.6. So this problem, if you kind of zoned out thinking, I got this lesson down, this is the problem that you, if you zoned out, are going to struggle on Alex on. So here's what this problem means. There are the numbers 6.2 and negative 1.6. These are like the bookends of a sequence that has 5 values in between them. So to kind of visually represent this, here's what I'm going to do. Put 6.2, do a comma, and write 5 like blanks separated by commas out. So that you can visually see what's happening here. And then have as your other bookend negative 1.6. You follow what we have there? Now that you visually can see it, it makes it a lot easier to identify the problem so we can solve it. What does 6.2 represent? A1, the first term. What would negative 1.6 represent? There are 2 ways you could write it. You could call it AN, or you could call it A7. 1, 2, 3, 4, 5, 6, and 7. Now, if you call it 7, which it is 7. What does that mean? N equals? N equals 7. Okay, so here's the deal. We have to find the 5 numbers that go in there. The only piece of information from the formula chart that we don't have is the D. So we need the formula chart or the formula value, which is AN equals A1 plus N minus 1 times D. Let's plug in our values to solve for our common difference. We know AN. What is AN? Negative 1.6. We know A1. 6.2. We know N. We do not know common difference. Let's do some algebra. According to PEMDAS, we should do 7 minus 1 first. So negative 1.6 equals 6.2 plus, I'm just going to say 6D. Are y'all okay with that math? All right. Now, how would I solve that using my algebra? Subtract 6.2. Since D is a power of 1, I can just isolate it and have my value. I don't have to factor. Negative 7.8 equals 6 times D. 6 is multiplying. What's the opposite of multiplication? Division. So to get our answer, we'll just, not our answer, but our common difference, we'll divide by 6. D is, I hear 1.3. Positive or negative? Negative 1.3. Okay, so here's what that means. We should be subtracting 1.3 all the way down. Before we do the work though, just to make sure we did this correctly, I'm gonna go to the calculator. And it's helpful just to see this again. The very first term, were we given the first term? 6.2. And that is first one term, so let's leave it as t is 1. So that means A1, since t is 1. The last term, negative 1.2. And we said that's the 7th term. So A7 equals negative 1.2. Okay, our common difference? 1.6. My bad. Thank you. And our common difference, do we know that? That's our x. Zoom in here. The intersection's your answer. This says it's negative 1.3. Is that what we had? Perfect. So we did our math correctly. That part is right. Now that I have that, let's go solve this. So I subtract 1.3 all the way down. If I subtract 1.3, what do we get? Mental math. 6.2 minus 1.3 is 4.9. Good. And then you subtract another 1.3. 3.6. And we'll do this again. We subtract 1.3. And I'm hearing 2.3. Okay. And then we subtract 1.3. Just 1. I could do 1, or I'll do 1.0 just to have one decimal place all the way down here. And last time here, I subtract 1.3. Negative 0.3. And if I checked it, if I subtract another 1.3, would I get? Yeah, that looks like it. If I subtracted 1.3, that would equal. So we've done this correctly. All right. Your turn. I want you to try it. Again, this one said 5 arithmetic means. That was like the blanks. Okay. This time you have to do it with 5 arithmetic means between those two numbers. DOL number 4. So now let's talk about writing. All right, example 5, second differences. It says find a quadratic model for the sequence. And it's shown here. Now, what I want to first note about this problem that I think is a little busted is this comes under the lesson of arithmetic. And I understand why, because the sequences you look, well, I'll get to that in a second. But first, what I want you to note is I did not, Mr. Voorhees does not consider this arithmetic. Does not consider arithmetic. Because you can't solve this using the same formulas we've been using all day. But I understand why it's in this lesson, because it has a second difference. And here's what that means. If you look at it, the first value from 0 to 5 is increasing by 5. The next from 5 to 12 is increasing by 7. 12 to 21 is increasing by 9. 21 to 32 is increasing by 11. And finally, you can see 32 to 45 is increasing by 13. Well, if you look at that, though they're not all the same numbers, you can see that if you took the differences of the differences, you'd see that those are all increasing by 2. So again, the difference of the differences is increasing by 2. And so you have a common second difference, which would be the quadratic for that reason. That's second differences are equivalent. So there's a way of coming up with an equation for that, which I'll show you in a second, but they're the easiest way. Anytime you see model, I have a calculator for that. Let's go over to our calculator list. Calculator models. We're looking for number 7. I'm gonna open that up. And here's how this works. The first term, A1 equals 0. A2, let me write that up above. This is A1. This is A2. This is A3, and so on. And so the 1, 2, 3, that's gonna be my X values. So it looks like on this one, we have 3, 4, 5, 6. We have 6 numbers here. That would be A6. let's type in our data 1, 2, 3, 4, 5, and 6. And the y values will be 0, 5, 12, 21, 32, 45. Now, my standard here is a quadratic, which is great because that's what we need. You see how this quadratic line represents, or curve, I should say, represents these data points perfectly. So what I'm going to do now is drag these over to our notes. And for our problem, this is how you'd write the equation. Get that here. All right, what this is saying is here's your formula for a normal quadratic. But instead of saying y equals ax squared plus bx plus c, instead of saying that, that's a normal quadratic. What we're going to do is actually an equals an squared plus bn plus c. That's actually going to be the formula we use. And so for this particular problem, let me just kind of lower that. I'll do it right there. We would say for our answer that an would equal, the a value is 1, so it'll be 1n squared, which will just be n squared, because a is 1, b is 2, and c is -3. So an squared, 1n squared plus 2n minus 3. And that will be my equation there, where my b is 2, my c was -3, my a was 1. Are those my numbers? Yes, 1, 2, and -3. Now, if you're wondering, how would you do that by hand? Well, there's a formula for that. And that's this. On the second differences, the second difference right there, that value is always going to be equal to 2a. So 2a would equal, 2a would equal 2. So in this particular problem, if you were solving by hand, you would divide by 2. And we would have established right away that a equals 1, which is exactly what the calculator said down here, that a was supposed to equal 1. So I'll just put a little check mark next to it. We did that part right. Okay, now the a1 is always going to be a plus b plus c. So I'll say this right here. A1 by formula is going to equal a plus b plus c. Well, right now I know a, but I don't know b or c. So before I find that, the c value is always a0. So if that's a1, then c is going to be represented by a0. So as I can see, this was adding by 5, 7, 9. Okay, so what would it need to add to c to get 0? The answer is 3. I would need to have c plus 3 to equal 0. And so before I can solve this, I would actually need to solve the value that c plus 3 equals 0, c plus 3 equals 0. It's from right there. Let me draw an arrow for that. And which would mean when you subtract your 3, that c equals -3. Which is exactly what it was supposed to equal. So I'll put another check next to that. We did that part right. And so now I'll go ahead and solve this portion. Let me just get a little space here. Well, that's not working. So now I could say a1, which we know is 0. A1 is 0 would equal a, which is 1, plus b, and then plus c, and c is -3 minus 3. So combining our like terms here, 0 you would equal 1 minus 3 is -2. So I'll say b minus 2. And when you add your 2 over, lo and behold, look what we get. B would equal 2. And that's exactly what it was supposed to equal. You can check that out and see that that does match right there. So that's how you can do it by hand. Again, that's a lot more work than just typing in the calculator. So I'll let you type these in the calculator. Just remember, that's A1, A2, A3, A4, A5, meaning your X values would be 1, 2, 3, 4, 5. These would be your Y values. All right, let's take a look at finding sums. So they give you some formulas here. It's not the way I'm going to do the formulas. Here's how I'm going to teach you to do the sums. It's not going to be from the formula chart. Here's what I want you to do. well, I'll explain it from the formula chart, but I'm not going to use the formula they suggest. Here's your formula for arithmetic. The arithmetic formula is this. We know it's AN equals A1 plus N minus 1 times D. Did y'all agree with that? Seen that today? If you need to find the sum, I want you to see what I do here. The sum formula, you do this, sigma from n to 1 up to whatever n is supposed to be. I'm just going to put n there. And parentheses A1 plus N minus 1 times D, which again, your ones correspond. I want you to see, what did I do that was different? What did I remove from the actual formula to the sum? What did I remove? I removed AN equals, and instead of AN equals, I replaced it with sigma n equals 1, all that. So that's what gets replaced. You put a parenthesis around the whole thing. Other than that, it'll solve the problem. So in this one, to find the sum, we're going to do n equals 1. Do we know how many terms there are? No. Do we know A1?
Yes.
Yeah, what's A1? -3 plus, do we know how many terms are going to be? Oh, for sigma, never, on the sum formula here, never replace this n. Put on there, never replace n when using sigma. Never replace n when using that symbol for sigma. That stays there. So what I'm going to do here is in parentheses, we're going to leave this as n. That n will not change. You do not substitute that. That's not a mistake. -1 times the common difference. And what is our common difference on this? 2 minus a -3. I agree. That is 5. When you change your signs, they are increasing by 5. So we'll put a 5 right there. Close your parentheses. That's what the sum is going to equal right there. That'll give us our value, but we first need to find out how many terms there are. So let's go over to our calculator, to arithmetic, to find out how many terms there are. What's my first term? -3, and that is the first term. The last term, do we know what the last term is? 157, so put that there, 157. Do we know how many terms there are? That's your x. Your common difference is +5. And I zoom out, we find out that there are a total of 33 terms. That's a 33. Now, here's a quick way to get your solution. If you scroll down here, you see the sigma at the bottom of the calculator? All you have to do is put a 33 right there. Now, once you know the answer, you put a 33, it gives you your answer. 2,541. This equals 2,541. That's my sum. So how did I get that? I first used this value here in the calculator to find out there were 33 terms. So I did that first. We found out there was 33. And then I scrolled down and I put 33 in the place of sigma down below. And that's how I got my solution right there. Those two steps. Okay. Part B. It says find the 17th partial sum. So I guess I could have noted here, this was AN. I didn't do that. That's AN and this was A1. I should have noted that just so you have that for your notes. Okay. Part B, it says find the 17th partial sum. That's basically saying find S of 17. Given this series, what is 53 the same thing as? A1. If I needed to find my common difference, how would I do so? 31 minus 53. Anybody know what that is? -22. Very good. So here's your formula. The sum formula. That's all I call it, the sum formula. Remember, you take away that AN equals and you replace it with sigma. You start with n equals 1. Do we know how many terms are going to be? That's right. N is 17. So I put a 17 there. Do we know our first term? Plus, and this n minus 1 is going to stay. That does not change. Do we know our common difference? Negative 22. You type that in the calculator, you will get your solution. So I'm going to go in here. I don't know. I know the first term is 53. Again, you could just type it on the blank line, what I have there, and it'll give you your answer. First term is 53. Last term, we do not know the last term, but we do know there are 17 of them. The common difference we said was negative 22. If I scroll down, the answer is already shown up. The sum is negative 2091. I don't need that 33 anymore. Negative 2091 is the answer this time. All right, DOL number 6. DOL number 6. All right, let's take a look at example 7. It says an artist receives royalties for all CDs of his music that are sold. For the first 10,000 CDs sold, an artist receives $10,000. And it's kind of showing the date that it's talking about selling CDs and not iTunes. But anyways, first 10,000, he receives $10,000. He receives $12,500. Oh, he's getting more money for the next 10,000 CDs and $15,000 for the next 10,000 CDs and so on. How much money would he receive if 500,000 of his CDs are sold? So first couple things, we want to talk about 500 CDs being sold, but I noticed it was counting in increments of 10,000. So 10,000, then another 10,000, and then another 10,000. It's counting by this. So first, what I'm going to do is find out how many increments would I have, which would be the value n. So n would equal, since I'm talking about selling 500,000, it's not in increments of 1 though. You get paid every increment of 10,000. So what I'm going to do is divide this by 10,000, which for the mental math, this will be easy because of zeros canceling with one another here, simplifying out those all. And so it's 50 divided by 1, which happens to be 50. So n is 50 in this problem. And I also notice that my value I get changes each time. So the difference, if you took the second term minus the first term, is 12,500 minus 10,000, which means each time there is a difference in 2,500. This is money here, so I'll put dollar signs. All right, and the first term I receive, the first amount I receive is $10,000. So I'll call it A1. Again, that term would be 10,000 divided by 10,000 because it's the first 10,000 and we're counting in increments of 10,000. So A1 is what that would be. That'll equal $10,000 in money. How much money would he receive if 500,000 of his CDs are sold? So how much money would he receive? This would be a sum. That's a sum here. So we want to know the sum. So what I would be using is my sigma formula. Let me remind you again. So the formula chart says this, that AN equals A1 plus N minus 1 times the difference. The sum formula, all that changes is instead of saying AN equals, we say sigma equals, where N starts at 1, of your A1 plus N minus 1 times D. That, and again, we do not change this n. Do not substitute. Where you do put n is up here on the top. That you do. We change that one to purple. That n. So we're looking for the sum formula this time. And so what we could type in the calculator on a new line, if we did not want to use my calculator, is n equals 1. And we do this up to 50 times. And A1 is the first payout of $10,000. For the calculator, I better not put a comma. 10 and then 3 zeros. Plus, we're going to leave this as n minus 1 times the common difference of 2,500. Now, if we type that in the calculator, we should get the sum. And I'm going to go over to arithmetic, and I'll just use my own. So the first term is 10,000. It was in money. There's 10,000. And that is the first term, so t should be 1. The last term, we don't know what that amount is. So I'll leave that as x, but we do know there's going to be 50 of them to get there, 50 increments. The common difference is 2,500. If I looked on the graph for the intersection, there it finally is. I see they intersect. That's the last payout. That's the last individual payout, but I want the sum. That right there is the amount of money. Now, if this one was blank, if these were blank, what you would do is you type in the x, but it's not blank. We already got our answer. So on this time, let me actually take a picture of that so you have it. I'll put it over here so you can look at it later on that completed notes link. But yeah, that right there would find your value. Let me sort, send this to the back so you can see written on top of it what I did. Oops. And so this would be the answer right there. That number is the answer. This would be AN. That's A sub 50 or AN. This is the S sub 50 or SN right there. That's what that value is. So how much money would he receive? He would receive $3,562,500. That's how much money he would receive. That's a whole lot of money. So now it's your turn. DOL number 7. All right, DOL number 8. Anna sells clothing in a clothing mall or at a store in a clothing mall. Her commissions on the sale of new seasonal merchandise is $3.50 per item, costing at least $25. To encourage an increase in sales, the store manager promises a 5% increase. Okay, that's the D right there. In commission for each additional item sold. Thus, on the sale of the next item, Anna would receive $3.55 in commission. On the sale of the third item, Anna would receive $3.60. So this is talking about A2, A3, and so on. How many items worth $25 or more will Anna need to sell for her total commission on new merchandise to be at least $1,000? So here's what we have this time. So this is kind of interesting. This time, they're saying that the sum needs to be at least $1,000. What we have so far is A1, the first amount she gets is $3.50. A2 is $3.55. A3 is $3.60, and so on. And which means our common difference is 0.05. All this is in money. What we don't know is how many she needs to sell. So how many items, that means the N we do not know. So on this problem, I'm going to have N equals X in my calculator. But we do know the sum needs to get to be not her total, or not just the AN, her total. So that's what kind of can be a little confusing on this one. So why do I say that? Because the formula, as I've given it to you, would tell you the sum. And right now, we don't know how many terms. We do know N equals 1. And you could play around with it. This is 350 plus N minus 1 times the common difference of 0.05. And what I could do is play around with this in the calculator. So I can plug in the numbers I know. 350 for 1. We don't know that value. We don't know we don't know how many terms there are, nor do we know the last. But I do know the difference is 0.05. So I have two different X's there. And what I could do, let me see if this will work out the way I want it to, is start to kind of play out. Okay, what if, you know what, that's not even working like I want it to. Let me show you what I'm trying to think of. I'm going to go to a blank calculator. I'm trying to talk through, and I might come back here in a moment. Let me just get a blank calculator to show you what I'm doing. What I'm going to do is try to find the sum, and we'll just play with down different numbers. So I'll type SUM. We're starting at 1, and we don't know how high to go. So let me see if I can do y equals like that. I'm not sure if this will work. We're just going to try it. And we know that the first term is 350 plus n minus 1, n minus 1 times the common difference of 0.05. So I have that all typed in right there. What I want to know is, when does my y get to be $1,000? Okay, and so if I zoomed out, I'm looking on the y-axis for 1,000. We can see how many I got to sell, and the intersection would be my answer. So I would need to sell at least, this is selling 143 basically. I'd have to, that's selling 142 in there. That doesn't get me there, but selling 143 does. So I would need to sell at least 143. So that's going to be my answer this time. N needs to be greater than or equal to 100 and, was it 43? Now that's my solution this time. So now how would you do this if this needs to be, that's $1,000? You could also use inequalities on the calculator and say the sum needs to be greater than or equal to 1,000. And you can see that this number, let me go home real quick and then zoom out one more time. If you compare this, you can see that that number is just to the right. That 143 is within, so you'd be shading. You could say n's got to be greater than 142 or greater than or equal to 143. That's the number of items you need to sell. So again, that's how you would solve that. Now, what you could also do, if you didn't want to use any of that, is you could go to the formula chart and use one of these sums. So like one of these formulas right there, and plug those in. We don't know the n value here, so that would be a little bit trickier, but you know the sum needs to be 1,000 or greater than or equal to 1,000, and you could solve that from there. That's another way of doing it, but I'll take the calculator for now. That I'll let you try DOL number 8. All right, let's take a look at how some released ACP questions have looked. The first three terms of a sequence are shown. There they are. What is the 49th partial sum? What symbol could represent the 49th partial sum?
AN.
Not AN if it's a sum.
Oh,
S 49. That's what I'm trying to find. So I use my sum formula. Remember, the sum formula is just where you take away the AN equals and you replace it with sigma. N equals 1. On this case, do we know how many there will be? 49. I need to put a 49 up top. Something happened on my writing board. So I would put a 49 right here. That's a 49. Then comes A1. Do we know our A1? Negative 85 plus n minus 1 stays. Anytime you use sigma, you do not change the n. Do we know our common difference? Negative 78 minus a negative 85. What do you get when you add those two together? Or when you take negative 78 and you add 85? Not negative 7, but positive 7. So the 7 goes right there. If you close your parentheses, that right there will be your solution. So using the calculator, first term's negative 85. Again, you could just type in what I wrote right there. That is the first term. We don't know the last term. That we don't know, but we do know there are 49 of them. The common difference we got was 7. And by the way, you could here put negative 78 minus a negative 85, and it would do the math for you until you had 7. So where they cross happens to be the last term. That would be the last term, 251. But if you scroll down, you get your sum is 4,067. Answer this one would be 4,067. Four, 0, 6, 7. That'd be the answer to that one. And finally, a theater has 35 rows of seats. Each row has 5 seats more than the previous row, and the third row has 34 seats. What is the total number of seats in the theater? So here's what I want you to know. This says this is the third row. Any idea what symbol we could say 34 is?
On the
How about A3? Why A3?
third term.
It's the third row. How much are these changing by?
5.
That's your common difference. D equals 5. Then it says there's 35 rows. If this is the third row, if the third row is A3, so that 3 is the row, 35 rows means N equals 35. If you want to know the total number of seats, that's a sum. That's a sum. You could do your sigma from N equals 1. We have a total of 35 N's. We don't know the first term, but we do know the third term. Can I use third term here?
Yes.
But if I do, I need to put N minus 3 times the common difference of 5. That would be my solution here. And again, you could use the whole calculator, or if you just want to do blank line, SUM from 1 to 35. The first is 34. That's really the third row. N minus 3 times 5. And why is it not giving me an answer? Oh, it's because I have an N right there. Let me take that away. 3815 is the solution here. 3815, which looks like the answer is